This video, I'm of two minds because there are two conversations that I want to have. The first is just an introduction to Excel. I want to go through kind of the basics of labeling and also typing in. The second one is a bit of statistical work and showing data, qualitative data, through graphs. If you're not interested in the Excel, you can simply look at the progress bar and find the bookmark to talk about statistics. But if you're new to Excel, this will certainly be to your benefit. In fact, let me dive right in to the first bit, introduction to Excel. I have some instructions here that we'll walk through and practice together. And so what I want to do is pull up Excel, and I encourage you to do the same. So let me pull up Excel, and I'll model for you guys what I expect to see. So most of you, if you simply type in the start button and you type Excel, it'll pull up for you automatic. If you don't have it installed, I can show you that at a later date. But I want to start just with a blank worksheet. I'm going to zoom in just a little bit. You can see in the bottom right-hand corner, there's my Zoom window. I want to just open up Excel. This is dark mode. Yours might look a little different. I want to walk through some of the processes of the steps to get comfortable. Again, I'd encourage you, if you're new or not sure what Excel is, I'd encourage you to try to follow along as best you can. Here we go. I want to get into it. So there's a couple names and ideas that I want to portray here. And then as you can see, each of these, they're called cells, but you can think about these like an entry point on a database, on a list, and say, hey, look, these are the items that I can put in here. Each of these cells have names. In fact, if you see up at the tippy top, the upper left-hand corner, this one has a name. It's A1, and I can scroll down and look at some other ones as well. Let me move myself over in the corner. There we go, it's a little better. And I can look and see these names. I want to work inside of this sheet. Now, if I scroll this over just a minute, you can see at the bottom, it says sheet 1. You can generate additional sheets and work inside of each of them. We'll just start with the 1, and really that's all you'll need for the majority of your tasks. But I just wanted to highlight that this is technically a spreadsheet in this big workbook. Let's dive into some of these examples. So what I want to do is practice referencing these cells. And so in A1, and again, I have it selected here, you can double click to start typing in there, or if you have it selected, you can just type in A1, and that references the cell A1. You can use the arrow keys, like I'm doing here, or you can simply use your mouse and select B3. So that's column B, row 3, and I can double click and type in B3. So that's again just referencing their names, and again, you can see that in the upper left, the name, and then what I typed in as well. Now that's going to be beneficial here in a moment, but it wouldn't be a start unless we typed in, it says C1, I want to type in hello world. And I can type in these things again. These are just cells in a data list, or you can think of them as new lines on a Word document. I want to do a little bit of calculation though. Again, we can type in words and letters all day, but ultimately what Excel is going to be a very powerful calculator for us to use. And so I want to demonstrate that to you. Down over here in C2, I want to type 15, and then in C3, 7. So C2, I'll find real quick. I'm in column C, number 2 there. I'll double click, and you can type in 15. And then the one below it, C3, I'll type in 7. Again, numbers, pretty insignificant to type. The power becomes in the calculations. So I want to add these two numbers together. I'm going to show you 3 different ways to add these numbers together. Let me show you the first. The first is what we're used to. You can type in 15 plus 7, although Excel doesn't quite understand this the way it's written, because it says, oh, you want to type in hello world or B3, that's fine. If you wanted to do a calculation, let me double click. If you want to do a calculation, you need to type in equals. And then it says, oh, look, I know what you're trying to do. You're trying to do 15 plus 7. And you can see that typed up here, equals 15 plus 7. In order to show it a little better though, let me do a little tick mark in equals. That little tick mark tells Excel, hey, ignore the equal sign and simply show what we're working with. But 22 is what I'm going for. But again, has the work hidden in there for us. And you can do this for calculating things all the time. In fact, we'll demonstrate some later in the statistics portion. But there are other ways that you can add things up as well. Let me scroll down to the next slide here. So this is close to what we have. I don't know why there's a 9 there. Anywho, as I scroll through, there's other ways that I can add things up. We mentioned earlier these cell references, A1, B3. Well, this 15 and 7 also have their own cell references. I can add using those. If I go in C5, double click again, I'm going to do a little calculation. Remember, equals. Now, when you type equals, either I can type in C2, and it says, oh, you're referring to C2, or if you'd like, let me backspace that, you can click C2, or you can click the 15 and it knows the reference that you're referring to. And then I'm going to add that with the one below it, and I'll type this one, C3. So typing, clicking, both are the exact same. Let me highlight these and write them for your reference. So cell referencing is the most powerful. That's the way that I would encourage you to do it, because this is what puts us above a basic calculator. Because check this out. I have 15 plus 7, 22, of course. If I change one number, let's say this to a 9, hit enter, and the 15 plus 7 did not update, but look at that, the C2 and the C3 did. And so that's the power of cell referencing, is I can make a formula once, like adding these two numbers together, and then simply updating them updates the sum as well. Speaking of sum, here's my third way I want to show you how to add numbers together, and that's using functions. Excel has a plethora of functions, built-in calculations to do. Instead of you writing plus, 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 and adding numbers together, you can simply use the sum function. If you type in S, you can look for it, and I don't see it. Let me type a U. There it is. SUM. You can either double click or you can finish the typing, but I'll double click and it'll say sum, and it wants a range of values to sum up. Now, if we'd like to, we can scroll up and I can simply click, hold down, and drag, and there it is, C2 to C3. Otherwise, I can literally type that in. I want to add up C2, and I want to keep going. I'll do a colon all the way to C3, and it says, oh, I know what you want. You want me to add up all of those different cells, and it'll certainly add them up, no problem, again, using the sum feature. And there are a lot of sum features. Anytime you hit an equals, in fact, if you just started typing in normal distribution, that'll be something for a later date. There are all these different functions that it can perform for us. And the first one that I want you to try is this sum one. Very friendly. In fact, I can sum up a bunch of different stuff. Boom, and it'll sum it up, no problem. A very powerful feature to do. Again, a lot of ways to work in Excel. I'd encourage you to treat these cells like their own little databases, their own little lines, entries to put in, and that's certainly something we can perform. And look, Excel has a lot of functions built in. There is an additional toolpack you can get. Again, you don't have to, but it should look something like this. It's called the Data Analysis or Data Analytical Toolpack is often what it's referred to. Again, we don't need it, but certainly something that you should be aware. That kind of wraps up the Excel portion here. Again, opening up and typing in, and something that's important to get comfortable with, but not necessary. Let me get into the actual statistics portion here. And this is where I want to introduce or talk about descriptive statistics. Descriptive statistics, we want to describe things. We're going to describe things first off talking about qualitative data. These are data that are categorical in nature. Let me put myself up here. All right, there we go. So I want to talk about displaying and interpreting qualitative data. And the first question to kind of bring up is to say, okay, what do we mean by qualitative data? You'll remember qualitative data is data which is categorical in nature. Some examples might be something like hair color is a good one. Again, something that we can fit in categories that we can put things into. There's also many others. For instance, we could say status at college. And by status, we could talk about freshman, sophomore, junior, and senior, and so on, right? And we could have these different categories that we put people into. This is what qualitative data looks like. Now look, one of the worst things ever is to look at a bunch of qualitative data in a huge sheet. You can imagine if I had, let's say, 1,000 students and I had all their statuses put up here. So I had freshmen, a bunch of those. I had sophomores, a bunch of those, and so on, juniors and seniors as well. A huge list, 1,000 people. It'd be pretty hard to look at that list and say, oh, look, I have this many freshmen, this many sophomores, or even see a trend if I could see where most of my students, or the least, are located. And so to that end, we need a way to organize this qualitative data. This is going to be a big term that we use quite a bit, and that is frequency distribution. This is essentially a table filled with all of my data condensed down into a much more concise form. This frequency distribution has some components. Let me introduce them to you. The first one is class. Now, whenever you hear class, think this is really like category. These are the different categories that exist. And so when I was talking about the status at college, the freshman, sophomore, junior, senior, those are my classes. So I chose it. Of those classes, we can count them, and that's the frequency. It's literally just the count. How many of these occurred in each? That's the simplification. After the count, in fact, let me show this little chart here. So up top, I have my classes. If I'm doing letter grades, I have A, B, C, D, F. These are my different classes. And then, of course, they have their count or their frequency listed here. And it's much easier. Instead of looking, if I add all these up, I should get a number like 32. Instead of me looking at a huge data list of 32 different letters, I can quickly pick, oh, look, the most response I got was B. The second was a C, and so on. Much easier to see in a frequency distribution. Not only do we have frequency, oftentimes we're very interested in relative frequency. Relative frequency, think of percentage or a proportion. But this is, hey, how relevant is that frequency in your overall group? And so we'll talk about that in a minute, but you can think about that just frequency divided by sum. So we have frequency distribution to organize. We have these three different components: class, frequency, and relative frequency. Something important to keep in mind. Let's do an example of organizing a frequency distribution. Move myself over here. There we go. It's a little better. Example 1, 25 people are polled about their political affiliation. The opinions in the poll are R for Republican, D for Democrat, L for Libertarian, I for Independent, and lastly, O for Other. We have the results below. Here are these 25 individuals, and we're going to round our answer to 4 decimal places. Make sure we include relative frequency, and we certainly will. Let's see if we can demonstrate here. So I have all my data. Luckily, my classes are already filled in here. This is my political affiliation, and we can simply count these up. Now, there's a bunch of different ways to do this. I would encourage you to be as methodical as possible. That is, look, I see a D, I'll cross it off, and write a tick mark here, and so on. D, tick mark, and so on down the line. That's 3, 4, 5, 6, 7, and 8 should be my count. So I can have all my tick marks. And so my frequency or my count is simply 8. Let me see if I can change color. Let's do it. Pick something else for Republican. Red would have been a better color. All right, for our Republican, I'll cross off the other way. That's 1, 2, 3, 4, 5, 6. I have 6 Republicans to speak of. Yep. All right. Libertarian, I think it's light blue, technically speaking. So I'll pick a light blue as I can. Again, for Libertarian, we're looking for the L's floating around. I'm not seeing too many. Oop, there's one. I'll try to use different shapes to help highlight the different classes, and that way we'll make sure we count everybody. There's 1 L, 2 L's, 3 L's, and 4. That should be it. 1, 2, 3, 4. And so I'll put my count here. It's 4. All right. Next up, all right, I for Independent. And I can count these up. Here is 1 I here, 2, 3, 4, and 5 I's. Nice. 2, 3, 4, 5. 5 I's to speak of. And here's my last and final pick. I think I want to pick orange for other. Let's do little squiggly lines. 1 for orange and 2 for other. That should be it. Let's see. 1, 2. 2 for other. Oof, that is really hard to see on that color. Let me change colors. I apologize here. Let's pick this light red. Just a 2 for other. So those are our frequencies. Again, the data has been extracted and put into our table. It's time to organize that table just a little bit. Again, I want to add these up and make sure the total, I should know what the total is before adding them up, because it says it right here, 25. And that's oftentimes the case, but I'd encourage you to still add them up. That way, if we make a mistake, it's easy to identify. 8 plus 6 should give us a number like 14, plus another 4 gives me 18, plus 5 should be 23, and lastly, plus 2, there it is. That total is 25. So we can sum up and figure out that class frequency. And again, the total's a nice gravy on top. For relative frequency, I can pick this apart. For relative frequency, we always want to do frequency over our total, or the sum in this case. For Democrats, I have 8 of those, so it should be 8 divided by my total of 25. These numbers should work out friendly for you. Again, if you want, you can get a basic calculator out. This number should work out nicely to be 0.32. Or if you want to write it as a percentage, you can write that as 32%. We can continue on here. So the next frequency I have is 6. Those were my Republicans. There's 6 divided by, again, the same total, 25. That should give me a decimal of 0.24, or 24%. Next up, for Libertarians, I have 4 of those individuals. That's 4 divided by 25. That should be 0.16. Some of you are noticing a pattern. I'll give it to you here. 8 times 4, that's 32. Because if I times this by 4, then that puts that over 100. And that's where these numbers, that's why they're working out so nicely. 8 times 4, 6 times 4, 24. 4 times 4 is 16. Let's continue the pattern here. For independent, there are 5 of those individuals divided by the 25. That should be 0.20, or if you want to write that as 20%, 16% above. I almost forgot. Lastly, I have 2 others, so it should be 2 divided by 25. That should be 0.08, or better written as 8%. And just like before, I'd encourage you add these things up. If you scroll down, 0.32 plus 0.24 plus 0.16 plus 0.2 plus 0.08, you should end up with 1.00. Or as a percentage, that's 100%. And this is how we build out, we extract our data and put it into a frequency distribution. I have a little trick that I want to show you though. We don't have to necessarily count this by hand, especially if we have more powerful tools. Here's that more powerful tool. In Excel, there's a very powerful tool. It's called CountIf. Much like I showed you the function earlier, it was called sum, right? This function sums up items. This CountIf will count items. And so I've demonstrated what that looks like here. If you have all your different political affiliations into a list, and I typed up a little bit here for you what this looks like, instead of counting them out like we do, we can actually use this function here, this CountIf. And this CountIf function requires 2 inputs. It requires a range of values. Hey, what do you want me to select from? I want to select from A1, that's this first input, all the way down. Here it is. It's F4. And that's what this range selection does. It's the whole thing. And what do I want to look for? I want to look for the character D, and it'll quickly return to you, much like we typed in 15 plus 7. And we got 22. That was what showed. Well, this will just show 8. And it'll count for you. Let me move over to the side, get out of the way here. There it is. And so you can see the little type in and definitions down here. CountIf, your range, and your character, and it would count it no problem. And so it's pretty easy to then go through, once you have your function type, to simply copy and paste it, change your check for an R, or change it to an L or an I, and it'll count as things lickety split. One of the little notes let me see if I don't know if I quite get out of the way. Let me move back over here. Nice little note is anytime you're working on or pulling data, well, friendly enough in Excel, you can simply copy your data and paste it into Excel. And it makes it much more friendly than to have to physically count it. I mean, you don't have to, but certainly CountIf is a very powerful tool I'd encourage you to take advantage of if you'd like. Good. So we got into organizing our data into a frequency distribution. I want to talk a little bit about how to show that information. The first way to show, show is through a bar graph. Many of you have heard this before. I want to talk about a couple of characteristics, and also there's an example down below. But a bar graph always has your classes on the horizontal axis. So here it is. This is my class on the horizontal axis. And then the frequency or relative frequency is always on the vertical. And that's what this little example here shows, number of complaints. And so these are commonly how these charts are written. Let me get into an example and we can see what we can do with these bar graphs. Here goes. The bar graph below shows the number of complaints for 6 different airlines as reported to the U.S. Department of Transportation back in February 2013. If one thing you'll notice, if we started to count this, let's say this is like around 130, maybe this is around 120. Down over here, this is Delta Airlines. It looks like they got somewhere around 50 complaints. But for some reason, it almost is like these airlines are getting no complaints at all. Maybe they got, let's go with 9 complaints here, 8 complaints, and 7 complaints. Very, very few complaints for these other 3 airlines. And so the natural question then to ask is, can we then conclude that American, Delta, and United are somehow worse airlines or worse than these other 3 airlines because they have, and it's certainly obvious from the graph, that they have more complaints, if not the most? It's an interesting question to ponder, but something that should jump out at you is, I've never heard, or maybe some of you had, I haven't really heard necessarily of Alaska, of Pinnacle, and of AirTran Airlines. And so one thing that's important to take account to is, notice out of this 130, there may be 1 million passengers that took United, in which case that may be a small proportion compared to how many people, versus maybe in AirTran Airlines, they only had 20 passengers. Ugh, okay, well, that proportion's going to be much more significant. And so one big thing to notice with this graph is we need to consider the number of total passengers. And so a natural question is, well, how can we fix our graph, or maybe show a better picture demonstrating our information? Well, one way that we could do that, instead of showing frequency, is I could show somehow a proportion, or maybe we call it a relative frequency. Then, instead of playing or showing just the overall numbers, I would show a proportion, and that would maybe be a bit more accurate of a picture. Because again, maybe 7 out of 20 people were complaining versus this measly 130 compared to the million people that were flying on this particular airline. And so oftentimes relative frequency is the much more preferred, because again, we want to compare apples to apples, or even apples and oranges, at least the same shape. We don't want to somehow compare apple to elephant, right? These things are very hard to compare, and certainly it's hard to get an accurate picture just based on this graph. And so it's something that we need to watch out for, especially for these bar graphs. Just like before, there is a way that Excel will build these for you pretty quickly here. And so I'll just demonstrate the steps for you, if you will. If you select your data, again, just highlighting it, just like we showed earlier, and you click this insert ribbon, here it is on Excel, it's at the tippy top. Just insert, and there's a lot of different inserts you can do. You can insert a picture, table, all this stuff, but this is what I want you to click. If you look over on the charts and graphs, you'll see a bar graph, and go figure, in about a millisecond flat, it'll build that chart, where again, here are my classes down below, classes, and here's my frequency count above, because that's what I highlighted. If you selected your relative frequency, it would build a bar graph for that instead. As a one little note, you will need to rename your chart. It's not automatically going to know, oh, I know what you want me to put in there. So you'll have to rename it, but otherwise it builds these things no problem. And so if you ever see a graph or a picture that looks something like this, where a title and the bar graphs and the separation, guarantee you is made in Excel. Very common, very popular to use because, well, it's accessible, and we see it quite a bit. There's a very fancy kind of chart. Let me move out of the way here. There's a very fancy kind of chart that I'm interested in. It's a kind of bar graph, but it's a special kind. It's called a Pareto chart. And it's a bar graph, but where everything's arranged in descending order. Everything's going down, where my largest is at front, and it gets progressively smaller and smaller on my bar graph. These are very useful for identifying trends, right? I see the most and I see the least as we progress. And also there's a nice relationship usually that I can see as things change, well, then the quality is going to decrease as we go. So very useful. In fact, most bar graphs should be presented in this way because it's quick to identify the components. Let me show you a little example here. Consider the Pareto chart, which shows the number of student blood donors by their type for one day of a campus blood drive. Here's our question. What is the proportion of students who have A or AB blood? Proportion, again, think of like percentage or relative frequency. I want to know how many people have A or AB blood. Let me type, I know, for my chart here, I can see my count looks like people who have O blood, 45 of them. A, we're interested in that one, 30 of them. For B, 20, there's an AB, there's 5 of them. And so you might be tempted to write, A or AB. I can simply add these two together and get 30 plus 5, or the total is 35. You might be tempted to box that, but it's not quite correct because we're interested in the proportion, or better yet, a frequency. Whenever we hear proportion, we should always think, I know that's going to be frequency over the total. Well, I can get the total here pretty quickly here. If I need the total, I can count these together. That should be 45 plus 30 plus 20 plus 5. This should add up nicely. 45 plus 30 is 75, plus 20 is 95. Hey, look at that. Plus another 5 gives me 100. And so if I want to find the proportion, I can simply write that as 35 divided by 100. Now look, you can do this in a basic calculator. Some of you might even be able to do it in your head, but I'd encourage you to practice. Here it is. This is my little faux Excel box. Type it or write it like you type it. And so here, if this is an Excel, you might be tempted to just write 35 divided by 100, but that actually will not work. It won't give you the answer you're looking for. It's missing something. If you're thinking, what is it missing? I'll help us out here. An equal sign. Again, this tells Excel, hey, I want you to calculate something. 35 plus 100, or 35 divided by 100. There's your decimal, 0.35. And that's our decimal, our proportion there. Again, you can also write 35%, and that's looking pretty good as well for our, again, a proportion for how many people have A or AB blood. We talked about a bar graph. We talked about a Pareto chart. Now I want to talk to you about the third pie chart. This one's very commonly used. And the main reason why it's used so commonly, we talked earlier about frequencies on their own can be misleading. Well, pie charts always show 100% where they're divided up. Okay, forgive my crosshairs there, where they're divided up into different quarters or different sections. And it's very easy to see where the largest piece of the pie is located. So again, if you prioritize relative frequency because it shows portions better, pie chart is the better one to go with. Let me give you an example of how we can read and use a pie chart. The university admits 8,697 students and places all into various types of housing. The types of student housings are shown in the following pie chart. Find the number of students who live in a house. You might be tempted to see apartments here, dorms. You might be tempted to say, hey, look, there they are, found them. But it says number, that's a proportion. So let me write over here, I'll write number of students in a house. It's not quite 12.5%, but it is 12.5% of the total of all the students that are at this university. Let me see if I can turn this into a little bit of math. 12.5%, if I want to turn that into a decimal, I can move it over 2 spaces. That should be 0.125 of, it's just a fancy way to say multiply. So our little dot there to multiply the total. Look at the chart, I don't see it, but there it is up top. There it is, 8,697. And so we can simply multiply these two numbers together. You can multiply them. I can use the basic calculator. I'd encourage you to practice write like you'd type. And so just like before, I encourage you to start off with enter or equals, and you have 0.125 times, or if you're typing it, it'll be a little star icon up above, and then 8,697. And lickety split, no problem. We should get 1,087.125. There's something kind of wrong with that number. I can't use that number the way it's listed. Again, I want to find the number of students. All right, we're not going to start cutting students in eighths over here. 0.125 is 1/8. We're not going to start cutting students, talk about 1/8 of a student. Instead, we need to round it, and that's what our little hint says. We round this thing to 1,087, and we'll even give it some context and write students here. And there we go. We can go from relative frequency and get the number, or like we did in the previous example, we can have a number and get relative frequency. And so we read these charts and we can certainly get them a lot. Building these charts though, much like we showed earlier with the bar graph, Excel does for us fairly quickly. And the same is true for the pie chart. Let me get out of the way here. There we go. So if I want to construct a pie chart, you can do so in Excel. In fact, just like I talked about, you can highlight the classes and highlight the relative frequencies. Go over to that insert tab. If you ever want to do a graph, hit insert. It is the best. And then you can scroll over. This is where our bar graphs were earlier. Bar graphs. I want to select over here a pie chart, and boom, just like that, here's my different percentages. It'll create it in no time at all. The one note that I have for you is if you are going to name them, make sure you do take the time to rename the title, right? Give it a snazzy and give it something interesting that hopefully pops out and gives the information that you're most interested in. Let me recap with this. I like this one. Let me recap with this. So we talked firstly about the Excel introduction and encourage you to practice, get comfortable with it. We'll do quite a bit as the course continues. But we also talked about how to show this qualitative information. There are 3 big charts that we use, the bar graph, the Pareto chart, and the pie chart here. But the most important takeaway that I want you to get is exactly what's on this picture here, this frequency distribution. Like in a very nice table, instead of looking at the full chart of political affiliations, I can quickly get a glimpse and I can see, hey, look where my most individuals are. In fact, this frequency distribution is a conversation that we'll carry on and we use quite a bit. It has some useful properties that we'll talk about next time. All right. If you enjoyed the video, I appreciate your time. If you didn't, I apologize. All right. For the rest of us, I'll see you in the next one.